Okay, so today's lecture is on the systems engineering tasks, and the idea of this lecture is to somehow put together everything that we have been discussing for the past 4 lectures, involving the different type of system requirements, and then how do you go about describing the problem, describing the functions that will help you solve that problem, and then using that how to list the requirements for your system, and from there how can you build a buildable system, an implementable system, and so on. So the idea of this lecture is to go through an example that is most of you are familiar with, and see how the systems engineering process fits into developing this simple system, so you can have an idea of how to translate this information into building something more complex, like for instance your project. So the information, again, the lecture will tie together all the things that we have been discussing for the past 4 or 5 lectures, and also there's an additional reference here, which is from the University of Arizona, that is a good document to read. So, okay. So the idea, again, we want to go through the system engineering process and tie that to a very simple example. So as we discussed, our first task when designing, or we're trying to solve a problem by designing a new system, is to state the problem. State the problem in a way that is clear, and that is clear for both the customer and also for the person who is going to be building the system. And in stating the problem, we need to make sure that we understand what the real problem is. So when we design a solution for solving that problem, we are targeting the actual problem. So in this lecture, we're going to have a problem that is helping design a system to help our customer prepare and deliver a slide presentation. So you're familiar with different type, or like I would say the computer mostly is what you use to do this type of problem, or to solve this problem. You use the computer, you sit down, you work on PowerPoint most likely, and you can build a presentation using the computer. But let's think about not, when we are thinking about this example, let's just assume that you are not familiar with the PowerPoint and the computer. So you're trying to come up with a system that is trying to design, or you're trying to design a system that is going to help a customer prepare and deliver a slide presentation. So the foundation for a successful project, again, you need to make sure that you understand the problem very well. So complete the problem statement before defining the requirements. Remember, the requirements will be tied to your problem. So you want to make sure that you have a good understanding of the problem before you start defining the requirements. Avoid stating the problem in terms of solutions. So you don't want to solve the problem right away. You just want to state the problem, and this developmental process is going to help you to get to that solution. Involve the customer in the process of defining the problem and the requirements. The customer has to be involved because this is the person, or this is the group of people who are familiar with the problem that you're trying to solve. So in this example, our problem is we need to design a system to help our customer prepare and deliver a slide presentation. So after we understand the problem, now we want to identify the functions the system must perform in order to achieve that solution. In this, I'm listing just 2 functions here, just to illustrate the example, but this type of system must have a lot of functions. So I'm listing a top level function of what would this system do. A top level function will be to educate people, like we do here in the university. We use these systems to lecture and to educate the students. But a low level function, the system must also allow you to print slides. So if you want to have a hard copy of the material that you're presenting, then the system should be able to perform that function at the low level. Even though it's not tied directly with the actual presentation, you know that that is going to be needed in order for you to generate hard copies. So remember the problem statement. We want to design a system to help our customer prepare and deliver a slide presentation. And after defining our problem statement, then we want to look at what are the functions that this system has to perform. And I'm showing you two examples here. Now that we understand the functions, we have a list of functions. We now want to start specifying requirements. So these are the functions that the system must perform. These are the requirements that the system must do in order to achieve their goals. So specifying the requirements, for instance, maybe we need the system to perform some graphics as part of the functions. We want to have some type of illustration. So a requirement must be we want to have this type of graphs to be presented in our slides. Also, we need to have documentation with the graphics. So are we allowed to, is the system capable of if you try to type some information in the slides, can you do that? That's one of the requirements. It has to allow you to create some type of documentation with the graphics. Not only figures, but also text. More requirements, and these requirements that are listed in this slide follow the structure that we discussed in class. The use of shall, the use of should, the use of will. So as you can see, there are written following that format. So first, the system shall produce 8.5 by 11 inch color transparencies. And again, when you define this is done in conjunction with the customer. So the customer is telling you this is what I need, right? The printer shall print at least 10 slides per minute. So it has to be fast in some sense. The system shall use these type of electric receptacles. The system's resolution shall be at least 300 dots an inch, and the system will be replaced after 3 years. And finally, the total life cycle cost of the system shall be less than $18,000. So some of the way that this is written has a very specific meaning, right? We talk about those requirements that are going to be enforced, those that are not necessarily enforced. So you should know what they mean in that sense at this point. So after defining our requirements, then we want to move into validation and verification. Okay, and these are two things that are different. Okay, and in general, this is what they mean. Validation is building the right system. Verification is building the system right. So we talked about this already. Verification is looking at whether or not you're following the steps of the process in order to get to the last goal or to the last point. Validation is after you follow those steps, is the system performing as you're expecting? Like if it's giving you the output that you expect from the system, that is validation. So validating requirements means ensuring that the set of requirements is complete and consistent. A real-world solution can be built that satisfies the requirements, and it can be proven that a real-world system satisfies the requirements. If the requirements specifies a perpetual motion machine, then we know that the project should be stopped because that is something that cannot be done. Validating requirements. So in this slide, I'm showing you whether or not we have the technology to achieve the goal. So can we build a system to generate these slides? Well, if we can rely on a machine like a computer, that can be done. If we need to print, then at the other requirements that were specified, then we can rely on that printer technology to achieve that. Verifying requirements. Each requirement must be verified by a logical argument, inspection, modeling, simulation, analysis, test, or some type of demonstration. So after validation and verification of our requirements, remember the steps. We start with the problem statement, then we move into identifying the functions, then we move into defining our requirements, and then we move into verification and validation of those requirements. Now we can start looking at concepts. Okay, so we know what the system must do. We know what are the expectations. So using that information, can we build something that is capable of performing those activities and is capable of achieving those goals? So here's some concepts. So at this point, what we're trying to do is, okay, what are our alternatives in terms of technology that will allow us to achieve those goals, that will allow us to meet the requirements? So here I'm showing you 5 concepts in technology. We can use an artist, we can use a typewriter, we can use a Sun workstation, an IBM PC, or a Macintosh PC, or an Apple machine. So out of those, we can also look at alternative concepts. So the idea here is that can we, using those alternatives, can we project, like here, computer projection. We can also use 35mm slides, view graphs, or video discs. So these are alternative concepts in terms of visualization aspects. So the computer, this technology, will allow you to create the slides. These are other alternatives in terms of projection, showing the slides. We can use video discs, we can use view graphs, we can use 35mm slides, or we can use a computer projection. Okay, so out of those alternatives, now we want to model the system in the sense of, okay, so if I try to look at what of those systems will give me the best performance, now I want to model what will happen if I use a combination of these alternatives. So system design, we will have alternatives in terms of hardware, software, and maybe bioware. Maybe we can bring live animals to our presentations. Is that an alternative? Is that cost effective? Is that something that will help us? System design, one of the best ways to describe what the system should do is to list typical sequences of inputs and outputs as functions of time. Such descriptions of behavior are called sequence diagrams. So on the next slide, I'm showing you one of those sequence diagrams. This is in terms of a system that, that is looking at a sensor for a traffic light. So we have a sensor that is sensing a car waiting. Then that's going to trigger a message that is going to tell the controller, you know, this car is waiting, maybe we should change to red on the other direction. So that is sent through the router. The change of color, the light change. The change is confirmed. Then we change the other light to green. When the FR routers check that there's no other cars waiting, then it will change the color again, back to the previous color. So these type of diagrams is helpful in terms of seeing, okay, which system will meet the sequence of activities that we require for our system in a better way. Okay, so now that we have technology in terms of alternatives, we have information in terms of what the system must do from a functional perspective. We have the requirements. Now we want to see how can we meet those functions that the system must perform in terms of technology. So here's a mapping of functions to technology. So in terms of this particular example, the system should be able to accept input from humans, so we can achieve that through the use of a keyboard. The system should be able to produce slides as a function, so we are targeting that functionality in terms of technology by using a printer. The system should be able to store data, so we can have some of this technology. These are very old technology, floppy disks. Maybe you're not familiar with those. But we have a hard drive, check spelling with the CPU or the software in the CPU, and display picture with the use of the screen. Okay, so this is a mapping from functions to components. And remember this example that I mentioned already, what is the difference between physical decomposition and functional decomposition? The physical decomposition, we talk about flying. For centuries, the humans were unsuccessful on achieving this goal of flying because they were looking at physical decomposition instead of functional decomposition, which was what the Wright brothers were able to do. By focusing on control, horizontal trough, and vertical lift, they were able to make their airplane. Okay, so to summarize, the idea of this lecture is to take you through the main or the first stages of the system development process, from problem statement to establishing the functions of the system has to perform. From there, how to establish the requirements, which we've been discussing for 4 or 5 lectures already, and then how to map, after verification and validation, how do you map those functions into technology, so you can find out whether or not you have a system that you can, a functional system and a system that can be built, and also a system that can be implemented. So the idea again is to go through that process, and that is the purpose of this example.